Good day everyone. My topic is all about probing trigonometric identities. So, probing and identities is very different in concept from solving an equation. So, through your use many of the same techniques they have are not the same, and the difference are what can cause your problems. So, to probe an identity, you have to use logic steps to show that one side of the equations can be transformed into the other side of equation. So, you have trigonometric functions: sine, cosine, tangent, cosecant, secant, cotangent. So, 8 fundamental trigonometric identities. So, trigonometric identities, an equation that involve trigonometric functions which is true to any solution. So, first, quotient relations. So, tan theta is equals to sine theta over cos theta. And cot theta is equals to cos theta over sine theta. So, pwede din siya maging So, cos theta is equals to sine theta over tan theta. So, sine theta is equals to cos theta tan theta. And in cot theta, sine theta is equals to cos over cot theta, and cos theta is equals to sine and cot theta. And the reciprocal, so reciprocal, sine theta is equals 1 over cosecant theta, cos theta is equals to 1 over secant theta, tan theta is equals to 1 over cot theta. Pwede din siya in alternative form. So, cosecant theta is equals 1 over sine theta, or cosecant theta sine theta is equals to 1. So, in cos theta, pwede din siya maging secant theta is equals to 1 over cos theta, and secant theta is equals to secant theta cos theta is equals to 1. So, the alternative of tan theta is equals to 1 over cot theta. So, cot theta equals 1 over tan theta, or cot theta tan theta is equals to 1. So, in Pythagorean relations, they have sine squared theta plus cos squared theta is equals to 1. 1 plus cot squared theta is equals cosecant squared theta. And tan squared theta plus 1 is equals to secant squared theta. So, in alternative of sine squared theta plus cos squared theta is equals to 1. So, magiging sine squared is equals to 1 minus cos squared theta. And cos squared theta is equals to 1 minus sine squared theta. And in the secant, and the alternative of 1 plus cos squared squared theta equals cosecant squared theta. So, pwede maging 1 is equals to cosecant squared theta minus cot squared theta. So, cot squared theta is equals to cosecant squared minus 1. So in the last is tan squared theta plus 1 is equals to 6 secant squared theta. So the alternative of this is 1 is equals to secant squared theta minus tan squared theta. So tan squared theta is equals to 6 secant squared theta minus 1. So condition, so they have the condition to prove the given. So first, transposition is not allowed, and transform expression independently. So kung mo-transform ka is independent. So pag left side lang. So number 3, do not divide or multiply a common terms to both sides of the equations. So the last is transform the complicated side. So useful. So this is the rules to probe the So first, memorize the 8 trigonometric identities. And the second, express all function in terms of sine and cosine. And third, be familiar with algebra manipulations, manipulations. So factoring, special products, combining like terms is simplifying complex fractions. So example number 1. So sin x multiplied by cot x plus cos x tan x is equals to cos x plus sin squared x. So let's start by working on the left side of the equation. So sin x multiplied by cos x over sin x plus cos x times sin x over cos x. So the given code transform into cos x over sin x, and the tan x transform into sin x over cos x. So which is write the terms inside secant parentheses by using the quotient identities. So after that, sin x multiplied by cos x over sin x plus cos x times sin x over cos x. So simplify cos x. So cancel out cos x. So sin x is equals to cos x. Sin x is multiplied by cos x over sin x plus sin x over 1 multiplied by sin x and sin x. So to add the fractions inside the parentheses, you must multiply by 1 to get common denominator. So sin x multiplied by cos x and sin x is equals sin squared. So nagiging sin squared because i-multiply nato si sine x into sine x. So, nagiging sine x squared x over sine x. So now that you have the common denominator and numerator, so i-add natin yung cos x plus sine x squared over sine x. Copy the denominator. So sine x multiply by cos x plus sine x squared over sine x. So simplify, cancel out sine x. So ang nabilin is cos x plus sine squared x. So since the left side of the equations is same as the right side, you have successful to prove the identity. So this is the answer. So na-prove na natin yung first problem. So another example. So cos to the power of 4x minus sine to the power of 4x is equals to cos squared x minus sine squared x. So let's start by working on the left side of the equation. So we factor the term using difference of two perfect squared. So cos squared x minus sine squared x multiplied by cos squared x plus sine squared x. So using the Pythagorean identities, second set of parentheses can be more simplified. So the simplify natin on the second parenthesis, so magiging 1. So cos squared x plus sine squared x is equals to 1. So cos squared x minus sine squared x multiply by 1, so is equals to cos squared x minus sine squared x. So since the left side of the equation is the same as the right side, you have successful to prove. So ayun, same the answer on the left side and the right side. So ayun, madali lang mag-prove of trigonometric identities or to proving the equation. So that's all. Thank you and God bless.